Good morning, good afternoon even. I realized that I watched a couple of my videos and I don't ever make a greeting because I'm always like in the middle. I'm like, oh yeah, the video, and then I push play and I'm like, so anyway, and so hello. Right. I'm supposed to do that, like a little like nice thing. And I never give my objectives because I've already given them, and then I go, oh yeah, the video, and then I push play. So anyway, the objectives today are solutions stoichiometry. So we've done gravimetric stoichiometry, and you wrote a little list yesterday about how to do gravimetric stoichiometry. So what was that list? What's the first thing we do when we're doing gravimetric stoichiometry? We write a balanced. You're writing this too, right? Chemical equation. Then what do we do?
The information.
Good. Come on, catch up. Tatum's done.
He's on number one.
Pardon?
He's on number one.
The easiest thing when you're writing things from the board is probably not to read the board, but rather to listen to the teacher and write what you hear. You'll be faster. You'll be faster if you write what you hear. Plus, when you've got handwriting like mine, you can also then not have to read it if you're just writing what I said. So write a balanced chemical equation. And 2, write the info underneath. Okay, what's the 3?
Convert again to the right. I don't know like moles to like weight or weight to moles.
Which one?
Grams to moles.
So in number 3, if we were given grams, we need to convert that into moles of what we know, right? Of the subject that we know stuff about. Then Sabrina, what's number 4? It's what you said.
The ratio.
So we're going to multiply our answer by the mole ratio. Why do we have to do this step? What's the purpose of this step?
Cross the bridge.
To cross the bridge. What does that mean? Like that's our technique, that's what we visualize. But what does that mean, crossing the bridge? What are we actually doing with this mathematical step? Converting. Why do we need to cross the bridge, you guys? To find the moles of the other thing. Why do we want the other thing?
That's what we're trying to say.
That's what we're trying to find. Why are we over here in the first stream? Because that's what we're given. That's what we're given. So we need to convert the subject. The subject units. So we're going from moles of what we know to moles of what we don't know, or want to find out, or the question mark. Does everybody get why we do that mole ratio, the bridge? Right, we can cancel out the top units from the bottom units, and if we cancel out those 2 units, the whole, however many moles of copper times, let's say it's a 2-to-1 ratio, I don't know, 2 moles of silver to 1 mole of copper, that's from our balanced chemical equation. The moles of copper cancels out, and all of a sudden I've just converted from my moles of copper into my moles of silver, and now I can discuss silver, which is where my question mark is. Okay, so that whole point about crossing the bridge is to convert. I know stuff about the copper, I'd like to know stuff about the silver. Okay, it allows us to convert the units. And then 5, sometimes. Right, sometimes we have to then take those moles of silver, in my example up there, and convert it into the mass of silver. Happy? Makes sense, everybody? That's what your quiz is on in an hour or two, so I hope that you are comfortable with all that. Any questions on any of that? Okay, so I'm just going to erase these things here, just so it makes it a little bit more poignant, to the point. Okay, so solution stoichiometry. If I have a solution, I mean, we just finished the solutions exam, right? And I have some water with some things dissolved in it, and those things are probably ions, so plus, minus, right? What's actually reacting in my solution? Some of these pluses and some of these minuses. When you did your precipitation reaction yesterday, you added some other plus and minuses to this, and some of these reacted with some of these and made a precipitate. Does it matter how much water I have in there? If I filled it up a little fuller, does that matter? Would the mass change if I filled it up a little fuller? If I put it on a weight scale, would that have a different mass than that? Yeah. So the mass of a solution will change, but the number of moles, the number of circles inside, don't change. So for solution stoichiometry, pardon me, I can't go mass to moles, because the mass doesn't really matter of my solution. Do you understand what I'm saying? How do you figure out how many moles or how many circles are in a solution? According to our solutions unit. Number of moles in there is equal to? Pardon? C times V. My concentration times my volume. Does my concentration matter? How many moles I have in 1 liter? And then if I have 1 liter or half a liter, does that matter? Yeah. So concentration and volume matter in my solution, not grams. So I'm still going to write a balanced chemical equation. I'm still going to put the information underneath, but this time, instead of going from my mass to my moles, I won't be given mass. I'll be given concentration and volume. And I'm going to use those two to convert to my moles. And then, that's what I know about, but I still have to change my units. I still have to convert my units from moles of, now copper ions, probably, or copper sulfate, or something like that, a solution, into the other solution. And so I'm still going to use my mole ratio to convert those units from one subject to the other subject, from one topic to the other topic. Now over here, I might do moles to grams if I'm asked to find the mass of a precipitate, right? I might do mass, or moles, I mean, to concentration if I'm given a volume, right? So now I can play with two formulas. Here in the blue, for gravimetric stoichiometry, I only did this formula. N is equal to little m over big M. And then my mole ratio. That's the only formula I used. Now I'm going to be using, look, N equals C times V. This is for solutions, and this is for solids, or pure liquids, by the way. As in like pure water, or pure, not a solution. Do you get it? So now I could use either expression, either formula. If I'm asked about mass, I'm going to use this. Or if I'm given mass, I'm going to use this. If I'm given concentration and volume, I'm going to use this. Or if I'm asked about concentration, I'll use the green formula. Does that make sense? Are there any questions? So it's still the same steps, like I said at the very, very beginning of this unit. I said it's the same thing, just a little different. Can you see now? Same thing, just a little different, how sometimes I have to keep two formulas on my mind, not just the one. Okay, so we are going to spend today, well this class as opposed to the quiz class, we're going to spend this class practicing these. And I think it would probably be wise if we did one together before I released you to do whatever you wanted. Well, not whatever you wanted, I mean the rest of the questions. Okay, so step one is what, everybody?
Right, balanced equation.
Gosh, I can't get this marker off. Write a balanced equation, okay? So who would like to create this balanced equation for us? Austin,
What?
what's the equation?
Zn plus. What is the HBR?
Yeah, hold on. Good guess. What are my products, Molly?
ZnBr2
Very good.
plus H2.
Very good. Gas, because H2 exists as a gas room temperature, and I'd want to look that up to make sure it's soluble, but it most likely is. Do you have bromo in your thing? Bromide.
Oh, yeah. Yeah, it is aqueous.
Okay. And who would like to balance this for us? Everett?
2 by HBR.
Put a 2 by the HBR. Done? Good? Okay, that's step 1. Step 2 is info underneath. So what's the mass of the zinc? 4.36 grams. What other information have I got in there? Very good. The volume of the hydrobromic acid. And what's my question mark? Concentration of the acid. What am I going to want to do with that milliliters probably? Change it to liters. So 0.123 liters. Divide by 1,000. Okay, so step, whatever it is now, 3, is to figure, like I want to get to my mole ratio, so I'm going to need to convert this known into moles. Because the balanced equation is about the mole ratio. So the molar mass of zinc is 65.41 grams per mole. The grams cancel out, I'm left with moles for my units, as you probably already have memorized. Brandon? Brandon? Oh,
0.066.
0.466?
Just 666.
0.66 repeating?
Yeah.
Are you embarrassed to say 3 6s in a row?
Yeah.
It's actually really funny. You can say 6 repeating then. Okay. Sarah, we were just talking about Bible belts at staff lunch today, so that's maybe why I'm finding it funny. Okay, 0.66, and we'll round, so it's 667. Okay. Now I need to, that's moles of zinc, I need to convert it into moles of my acid, so I'm going to do that by zinc timesing my mole ratio, right? The mole ratio is 2 moles of HBr for every 1 mole of zinc reacts. The moles of zinc cancel out, and I'm left with 1.334 moles of HBr. And then my final step is to convert that into what they're asking for. So they're asking for concentration, right? Concentration is in, what's the units of concentration? Moles per liter. So what am I going to do with these moles? Divide them by the liters, whether you've memorized the formula or not. If I want to get moles per liter, I'm going to divide moles by the liter. So that many moles times 1 over 0.123 liters is going to be,
10.8.
go ahead and put it in the formula if you want to put it in the formula, if it looks better for you. Michael?
10.8.
And 10.8 moles per liter. Yes, Sabrina.
The moles of HBr should be 0.133.
don't think so. If I have 60 cents to multiply by 2, I should get $1.30.
It's 0.06.
Here?
Yeah.
Thank you. Okay, so I've got a couple points to make. Number 1, leave everything in your calculator the whole time. I might write a rounded answer, but I am certainly not changing my answer that's in my calculator. So I'm going to go, this is like one big full move. So 4.36 divided by 65.41 equals, answer times 2 equals, I think you did say, Sabrina, that was a 1 in there. I just have not put it in. Which is still a 3, if you notice. There's no 4, there's no rounding, so you must have put a rounded answer in your calculator to multiply that by 2. So you see how that's just changed? And then divided by 0.123, and you get 1.08 moles per liter. How many significant digits do I get? Do I have, pardon me? 3, so my answer better have 3, and so then I pay attention to my rounding to 3 significant digits at this point, not before. Okay, we had to practice that when we were doing our gases unit, keeping everything in our calculator until the very end. It's the same thing here. Any questions on that? Thanks for correcting us, Sabrina. No questions? We're good? Okay, so today we're going to spend practicing. Tomorrow we've got an experiment to do on solution stoichiometry. Please remind me that we have to weigh our precipitates from yesterday.